Okay, all right, we're live. Let's go over these problems. So starting with 12. These are of varying degrees of difficulty. In the scheme of things, 12s would actually be a pretty easy problem. I know it probably looks confusing now, but so they say g of x equals 3x times f of x. And they give you some information about f and f prime and g prime of 5. So obviously they're asking us for what is g prime of 5. So clearly it's a good idea to figure out what g prime of x is. Is there some expression we can write for g prime of x? So you go g prime of x. Now what do you guys think? What rule should we probably use here? Hinty, hinty. No. Product rule. Product rule. It's a product of two things.
I think we should use the quotient rule.
Who was the guy really mad when I would say timesing? Like, oh, it would be like, oh, it's like 3. It's because this says 3x. See, we're timesing 3x and f of x.
What was it, Noel?
Someone got really mad at timesing.
I guess teacher pet peeve was I would say minus for negatives.
Chemistry. That's fine. That's all right. Okay, so.
Why isn't it sine and cosine, secant and cosecant, and tangent and cotangent? You could have just named it to make sense, but you didn't.
Actually, there is a good reason for that. And well, it involves. Well, I don't want to get way. This would be a whole. This could be 40 minutes.
Just tell me where.
Real quick. It's real quick. So on the unit circle, you can when you draw this unit circle, usually you draw this. This is 1. This is theta. This is cosine of theta. This is sine of theta. And then you can draw this tangent line. And then I can't, off the top of my head, it's too hard to do, but you can talk about how the lengths of these like segments and stuff, there's like how they relate to tangents and secants and cosecants. So it's kind of like the cosecant. Anyway, that's if you start looking at that, you might see it actually does make a bit more sense than at first glance. Okay. So anyway, later on we can discuss that and create our line.
I want to.
That's the key though, is you draw that you draw that tangent line and you start examining like how long is this segment, how long is this segment, how long is this segment, and even how long is this segment, how long is this segment. Okay. And then who goes with who. Right, Aspen? Right. Yeah. Okay, g prime of x. So I've got thing times thing. So a times b. So the derivative is a prime b plus b prime a. Does everyone understand that? Yes. Are we sure that makes sense? That's the product rule in action. Okay. Now, okay, that's g prime of x. What's g prime of 5? So it'd be 3 times f of 5 plus f prime of 5 times 3 times 5. So all I did there was just replace every x with a 5. That hopefully makes sense. And so, now, if there was no more information given, you couldn't do anything else. But they give us, in the problem, f of 5 is 4. So this number here is 4. So 3 times 4. Plus, now f prime of 5, they tell us that's 2. And so we got everything we need. So it turns out the answer is 12 plus 30, 42! Amazing! I don't think that was on purpose or anything. Porpoise.
Yeah.
Well, now.
Oh, right. I love this. That's right.
Glad to hear it.
Yeah.
They're kind of fun.
I actually really enjoy the chain rule. I think it's really interesting.
All right, so just before I erase this, are there any questions on any of these steps? Like the first step, identifying it as a product rule type question, or the substitutions? No. Okie dokie. All right, let's try the next one. Hopefully we know the answer to this as far as what rule should we use here on 13.
Quotient rule.
It's a quotient, yeah, it's a quotient. So you got a thing divided by a thing. This time it's, the overall function is called h of x. And then there's this extra information given. By the way, I mean, don't lose sight of what you're doing here. What this is overall, what this is talking about is, if you knew all we would know about this graph f could look like anything. But for example, it could possibly look like this. This is just one example. You see how that graph kind of makes sense? Like this could be the graph of f. Has the point 2, 3 on it, and the slope at that point is -2. Make sense? Now what we're talking about is, well, what if I made a new function where I took whatever this formula was and divided it by x squared? So for example, that would probably create a vertical asymptote at 0, for example. But it would do, but we know for sure, it's kind of surprising, but the one piece of information we can know for sure is what the slope's going to be at 2. Figure that out. We'd also know what the y value is going to be, because that's trivial. You just plug in 2. Okay. H prime of x. All right, let's see. So we got to go. You guys think you know what to do? A divided by b. So f prime times x squared all. Does everyone understand that? Sweet. Sure there's no questions on this? It's not that easy. I mean, usually there's.
They looked a lot harder than it actually turned out.
Okay, sweet. Then we'll jump to so the chain rule ones might be a little bit more confusing, but we'll do 16 and 17. Okay, so look at this thing. All right, now h prime of 2 would be, all right, f prime of 2 times 2 squared minus 2 times 2 times f of 2 all over 2 squared. Does that make sense? It's a lot of 2's. F prime of 2, they told us that was -2. So -2 times 2 squared minus, that's 4. Now what's f of 2? 3. All over 4 squared, 16. So you got -8 minus 12, -20. So divide both by 4, turns out it's -5.
Just cancel 4.
Cancel what?
You could have just canceled 4. Here, I was over.
Out of here. Yeah. However, you want to do it. What makes these questions really, really, really difficult is the fact that there's not really any intuitive way to check your answer. Like on a lot of other questions we do, you can like say graph the function and know, okay, is this derivative that I calculated a reasonable number? On these ones, I mean, it sort of makes sense that if the slope here was negative and you multiplied it by 1 over x squared, this kind of graph, that graph also has a negative slope. I wouldn't really call that intuitive. I mean, it's not an obvious connection, but yes, the slope should be still negative. When you all say if you multiply this graph by this graph. But then again, that's because this is a positive y value and this is a positive y value. Anyway. Look at, okay, 14, let's not do it. 14 is a bit of a trick question. Actually, let's do 14. It's pretty, it illustrates an important idea. Do you guys see why I might call it a trick question? Yeah, this actually is a throwback to one of the first things we talked about regarding derivatives. Right, which is that if you know a derivative, if you multiply the function by, say, 4, what does that do to the derivative? Multiplies by 4. Like, for example, just another quick example, the derivative of x cubed is 3x squared. Well, what's the derivative of 4 times x cubed? Well, it's the same as 4 times 3x squared. So when you multiply a function by a constant, the derivative behaves very nicely. So for 14, do you guys see what the answer then to 14 is? 36. But, that being said, what if I use the product rule? What kind of answer would that give me? Right or wrong? Give me the right answer as well. So I just want to show you what that looks like. So let's say I don't make that connection right away, or I miss it. I'm in product rule mode, and I just go, oh, I'm just using product rule. I got this times this. Does it still work out? The answer is yeah. Okay. What's a prime though? That's the trickiest part. Derivative of him is 0. So 0 times g of x plus g prime of x times 4. And hey, look what that says. It says that the derivative of f is just 4 times the derivative of g. So when you plug in, 3. All right. Make sense? And also, keep in mind that that problem had a little bit of extra information, right? That we didn't need. Was it relevant that g of 3 was 5? No. So that happens sometimes too. With this kind of stuff is you get information that's extra. Do people still say extra? I realize that was like a. Do they, Aspen? No one says that anymore. Like, oh my God, you're being so extra right now. No, dang it. That's one of my favorite words. Okay. I can.
Yeah, definitely bring it back.
I just gotta wait for someone to be extra, and then I can call them out as such, and boom, I've breathed life into the meme. Okay, look at 16. 16 is a bit of a weirdo. Listen, it's not f times g of x, it's f of g of x. So what rule is that going to be? Chain. You guys might remember, hopefully you do remember, I mentioned a precise definition of the chain rule, which was this. So the derivative of f of g of x, and I said, well, there's certain kinds of problems where you need to kind of know this definition. Okay? And it's basically, it's f prime of g of x times g prime of x. In our old formula, when we use the u's, it's basically, this is f prime of u, and that's the u prime you tack on. Everyone cool with that?
Yeah.
Okay, so we're going to use this on 16 and 17. So for 16, the derivative of f of g of x is, let me write it, sorry. I was going to put g prime first, but why would I do that? You can if you want. F prime of g of x times g prime of x. And then it says at x equals 2. So let's plug the 2 in. F prime of g of 2 times g prime of 2. Everyone okay with that? Plugging in? This is where it gets a little interesting. Notice you're given 4 pieces of information. You're given g of 2, g prime of 2, f prime of 2, and f prime of 3. Why they give me f prime of 3?
Because G of 2, or 2, yeah, is.
Because g of 2 is 3, yeah. So what you got to do, you have to be really careful on this. So you have g of 2. So you go, okay, what's g of 2? Well, this information says that g of 2 is 3. So now this reads f prime of 3 times g prime of 2. So what's really weird here is that with the chain rule, do we really care what the derivative of f is at 2? Not really. We care about the derivative of f at 3, which is the y value of g at 2. So not obvious. So anyway, f prime of 3 is 4, and g prime of 2 is 5. So the answer is 20. Cool beans? Okay. Can we, 17, hopefully you can, same kind of idea. Instead of a, instead of just a function name inside G, it's actually an x cubed, a function you know. You can take a shot at that one on your own. Same with 18. Maybe we can, you might make a mistake or two, but we can come back and touch base and make sure you're understanding it correctly. But it's the same as this. It's a chain rule. So for full clarification, 17 is chain rule, 18 is chain rule, and 19 is chain rule. Those are all chain rules. And 20 and 21, 20 is chain rule, but the information is given to you as a chart instead of as individual pieces of information. And on 21, you got to use the same set of information to do chain rule, product rule, quotient rule, and then is there a plus rule for f plus g? What's the derivative of f of x plus g of x?
F prime of x plus g prime of x.
Yep. I guess that's a rule. It's an easy rule. It's just the derivative of f plus g is just the derivative of f plus the derivative of g. So that still stands.
Yeah.
I'm just to reiterate, I'm mentioning that because 21D is just there to be like, do you still remember that? Yeah, there's nothing fancy for sums. Okie dokie. So there's a bunch more like that. Tomorrow in class, we can make sure there's no confusion there. And the last two things, let's go out of order. If you look at the very back page of the graphs, you have a graph of f and a graph of g. And then it asks you to calculate f times g prime of 1 and f over g prime of 1. So let's just do one together, I guess. So it should make sense, hopefully. And then we'll end class with, if we have time, these. We'll do one or two examples from 25. Okay, yeah, we have plenty of time. So I can't believe how empty this class is. Sad. Big sad.
If you want to know what my dad said, he said that grades in law school matter if you want to get a job working for a federal judge the first year out of law school or at a big law firm, or if you want to be a law professor. But other than that, not really.
Good info. Good info to have.
Yeah.
Especially the first job thing. That's broadly true for almost any field. It's like, your first job out of college that, you might put your GPA in your resume, but if you're like my age and you're putting your GPA in your resume, everyone's like SMH in my head. Like, bro, don't put that on there. That was 10 years ago. Don't do that. But yeah, your first job out, yes. Or especially applying for internships, then that's the kind of all they have to go off of. But once you had a job or two, they're just gonna ask you like, where'd you work last? And what'd you do there? Okay, so 26. if I want to know what is, so this, again, this is another fun notation thing. F times G prime of, say, X. That just means, that's the same as saying, what's the derivative of F times G? Right, so you would just go, it's F prime of X times G of X plus G prime of X. Does that make sense how that's just another kind of way of writing, like use the product rule? Because we're talking about what happens if you, by the way, do you guys know what would happen if you multiply those two functions? You guys know what shape it would be? Yeah, a parabola, right? Because if you take a linear function times a linear function, then your result would be a second degree polynomial. Yeah?
Yeah.
So anyway, so F times G prime of 1 would be, now here's where you don't have to write out F prime of 1 times G. We know what it means now. So F prime of 1. So what's F prime of 1? Based on the chart or the graph. It's -1, very good. Let's make sure we understand what that's asking. F prime of 1 is just, what's the slope of the F graph at 1? Well, I mean, it's a line, so it's the same slope everywhere, right?
Yes.
So the slope of that line is -1. Okay, done. How about G of 1? 3. Notice it's not G prime of 1, it's G of 1. It's asking what's the Y value of the G function at 1. So you got to look up there on the graph. Everyone cool with how we got the 3? You sure?
G prime of X is 2.
Very good. G prime of 1 is 2, and F of 1 is 1. So it turns out the answer to this question, well, it's to save room, is -1. It's -3 plus 2. Any questions on that? Okay. So the next one is asking, what if you divided those functions? Now it gets interesting here, because what kind of shape do you get if you divide a line by a line?
Some kind of rotation.
Oh,
In this exact case, so say you did F divided by G. F looks like it's the function 2 minus X. And G looks like it's the function 2X plus 1. So, I mean, in these examples, I mean, if you really want to dig deeper into this stuff, you can actually write the function itself and take the derivative if you really want, but that's not really the point of the question. But does that make sense what I'm talking about? Or that actually is the formula for F over G of X, which we know would have a vertical asymptote at -1/2, et cetera, et cetera. So anyway, the point of the question though is, what if we go, so the derivative of the quotient would be F prime times G minus G prime times F all over. Right? So let's plug in. Let's plug a 1 in now. F prime of 1 is -1. Yeah, we're just doing the second. Yeah. Second for that. Getting the F over G prime. So it'd be -1 times, same numbers pretty much. So G of 1 was 3. So -1 times 3 minus 2 times 1. So same values from before, just now it's a minus instead of a plus, really. Over G of 1, which is 3 squared. So we get, it's an interesting number. -5/9. Assuming I don't have some sort of hiccup in there. Okay? Weird enough for you? Make sense? Okay, so, and then this kind of technique would be valid. I mean, they don't have to be lines. I would have made them curves, but then it's kind of tough to figure out what the actual slopes are. I guess the best, I mean, to make them more interesting, you can make them like little weird piecewise functions made of linear segments, but anyway, it didn't occur to me, I guess, when I wrote this. Okay, 25. Last thing today, then we'll be done. We'll go over an answer or two. I think these are really interesting questions, these last 4. You might find them stupid, but. So first, read it, as I'm erasing here, read this. Tell me if what it's asking makes sense. I'm curious about that.
What? I have the rest of the magnitude of the function and the derivative.
Yes. These are asking you to examine, take a function and examine the end behavior of the function and then the end behavior of the derivative of the function. Because there's functions, like this first one we're going to find. So it says, okay, calculate the derivative. So first thing, calculate the derivative. That's kind of boilerplate. Again, this is 25a. So f of x. Here's a good question, actually. Does anyone think they know the answer to both of those questions without doing any calculation?
Zero.
Which one? It's a good answer, but the second one is going to end up being 0. The first one would end up being
Oh.
3.
Yeah, okay.
So this is a good example of the kind of question where if you have a good understanding how graphs behave, then you can know the answer before you do your calculation, which is nice. So let's actually do it that way. I'll show you. We'll do the calculation together and all that good stuff. But that's to me that's like not the fun part. The fun part is looking at the graph and just kind of generally thinking about its behavior. So here's the graph of f. Here's the graph of f prime. So 3x. So the function is 3x over x plus 1. So does anyone remember anyone throw out like one feature of this graph? Think back to pre-calculus, like.
There's can't be -1.
Yeah, so -1 creates a vertical asymptote.
That was very good.
Huh?
Very good answer.
Oh, thanks, Jesse. It's
Yeah.
very kind. Y-intercept is 0. And if you think about the fact that, let's plug in 1,000. 3,000 divided by 1,000 is going to be pretty close to 3. And so this horizontal asymptote would be 3. With all that, that's enough information to kind of reason out that the graph does this. Now, just from that graph alone, can you see the fact that the function approaches 3, but the slopes get really flat? So the limit of the derivative should be 0. Obviously, class is over, so use the quotient rule, take the derivative, and then actually look at the two limits, and you should get 3 for this limit and 0 for this limit. Yay! See you tomorrow, guys. Tomorrow's a work day. Bring your problem set.